All right. Hi everyone. I hope you're all having a great weekend. It looks like we had a lot of trouble with mechanisms and resonance, so I just wanted to go over a few of the problems on the worksheet so that we can just clear everything up before the exam comes. So, looking at problem one, the first thing you want to do with these problems is look at the net transformation before you even draw anything. So you see that we have two molecules. I guess this would be called dimethyl sulfide or something like that. I don't remember. And this one would be called boron trifluoride. I'm pretty sure. I have not named things in quite some time. So you have two molecules here, and they come in to form one molecule. And they use one bond to do this transformation. So those sorts of things you want to keep in mind when you draw these curved arrows for the mechanism. So you're only going to need one curved arrow to account for this whole transformation. So the first thing it wants you to do is draw the Lewis structure. So I'm just going to do that without really explaining it because this isn't really about Lewis structures. All right, so don't forget your lone pairs when you're drawing these. It's really important. The teacher will probably take off points. A halogen normally makes one bond with three lone pairs to be neutral in a molecule. And one thing I wanted to say here is sulfur here makes two bonds with two lone pairs, kind of like oxygen, because it behaves like that. You'll see that sulfur is like right below oxygen on the periodic table, so it's going to behave like oxygen. So a lot of sulfur compounds are going to have this sort of electron arrangement around this atom. Anyway, so at this point you should be able to tell which one's the Lewis base and Lewis acid. This one has extra electrons to give, and so it's your Lewis base. You might get confused and say that the boron trifluoride is your Lewis base because look at all the lone pairs here. But if you look at the transformation, the bond is between the sulfur and the boron. So don't confuse yourself. The boron doesn't have any extra electrons to give. So that makes it our Lewis acid. And so now the last thing we have to do is draw the curved arrow. So you're going to take one of your lone pairs here because these bonds don't break in the final molecule, right? These methyl groups are still connected to this sulfur, so you don't want to do this and draw and connect this bond to this boron because that would be incorrect. So you're going to want to take one of the lone pairs that doesn't really have anyone to or anything to interact with and connect it to the boron, and so that'll facilitate the transformation you want. And you'll end up with this thing. All right, so you see that sulfur before it had two lone pairs, and it used one to make the bond. So now it only has one lone pair, and here's where the second lone pair is basically right here in this bond. And so now we want to calculate the formal charges on the atoms in the product. So sulfur, like I said, it behaves like oxygen, so it has 6 valence electrons in neutral sulfur. But here you can see that it has 1, 2 from this lone pair. Then each of these bonds counts as 1 because you're basically sharing 2 electrons equally. So it's like having half of 2 electrons. So each of these lone pairs counts as 1. So you have 1, 2, 3, 4, 5 electrons for the sulfur. And so 6 minus 5 in your formal charge formula gives you 1. And it gets the positive. And then boron here has 3 lone pairs in the neutral atom. And each of these bonds counts as 1 electron again. So 1, 2, 3, 4 valence electrons in the molecule. And you get a -1. So then you draw this little negative sign here. And then at this point in the exam, if you've really done your homework, you can, talk smack to the teacher, be like, haha, this was really easy. And, you should try harder to challenge me. And that's about it. I hope this helped. I think I'm going to do a few more of these from the worksheet. I'm sitting here holding my smartphone here trying to make this video, and I do not have the steadiest hand, so I'm not sure if this video was any good. Thanks, and have a great week. Good luck.